Hello, let's continue our Sudoku adventure with Extra Sweeper by GDC. So this continues our extra region theme week. Hope you're enjoying it. It's again circles that define our extra region, but let's define what these circles are doing. So we do have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have even sweepers in the grid. So what these are is whatever digit goes in here, say a 3, that tells you the exact number of even digits in its up to 8 surrounding cells. So it doesn't count itself. But within these 8 cells here, this would tell us that exactly 3 of them are even, and thus the rest of them are odd. All right. And I'm not going to give a blatant example of that. Hopefully that's clear. In addition to that, the circles do form an extra region, meaning they have the digits 1 to 6 exactly once each, just like a row, column, or box would. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I'm immediately seeing a 1, 2, 3 triple because this only has 3 surrounding digits. Therefore, it cannot exceed 3 in terms of counting the evens. That's going to be true of all of these in the corner. And since digits don't repeat in this circle region, that is a 1, 2, 3 triple, leaving 4, 5, 6 behind. Now, 6 here would be pretty tough considering there's only 5 surrounding it, so that is not the 6. But it does mean most of these are even, if not all of them. Interesting. What do I do with that? I'm not sure. So actually, 3 here is not possible. Because if this was a 3, these would all be even. And thus, this would be odd, but this would also be odd, right? So if this was a 3, these would all be even. And that forces the rest of the box to be odd. That would be 3. That makes this a 5. And then this is a 1, I suppose. It's odd as well. And so if this is a 5, though, this can't be odd because we need all of these to be even. So that's contradictory. So not a 3 here, and that means 3 is one of these two. That means these aren't 3. So is this 3 or is this 3? Does this have the similar issue? So if all of these were even, it's 4 or 6. I don't think it has quite the same problem. You know, what's interesting is I think 2 has the same issue because 2 is even itself. So if this was 2, it would be even, and then 2 of these would be even, say these 2, for example. But now all the evens are gone. This is still 5, forcing all these to be even, and this would be a 4th even in the box. So just another way to put that. So this actually can't be 2 either. So this is a 1, which is odd. All right. And so there's 1 even in these 3. Meaning there's 2 odds in these 3. This is the 3rd odd, and so these 2 are even. And so this actually has to be a 4, which doesn't surprise me too much. This is a 2 or 6. Okay, so that fulfills that. How about this one then? Oh, so we remove 4 from these, or remove 1 from both of these. So this is a 2, 3 pair now. So yeah, we know that 2 is even and would put another 2 over here and 3. So whether it's 2 or 3, all the evens are within this 2x2 box, meaning these are odd. And then again, over here, the 2 or the 3 puts all the evens in this 2x2 box, making these have to be odd as well. Sorry, it puts the evens in there. Sorry. Did I mess this one up? No, I made this a 1. That's how I didn't mess that up. Yeah. Makes these odd. That was the whole reason that this didn't work. Okay. We're good. I just confused myself for a second. So we know that these are odd, but they're not the 3. The 3 isn't one of these twos. That's the 3rd odd in this row. So this is a 1 to 5 pair. The 3 is over here, making these even, and we know the 2 is part of the 2, 3 pair, so these are a 4, 6. Okay. Now this one, we can have up to 1, 2, 3, 4, 5, 6 evens. But if we did that, this wouldn't be able to be a 6, right? If these were all even, that would be 6. However, we'd have 3 evens in the box already. So this couldn't be a 6. So it actually must be a 5, which is odd. That's 1, that's 5. That's a 6, which is even. All right, that's a 2. So this has to be the 3. These are both even. This is a 2, and that is fulfilled. This is 4, 6. This is a 3, which is odd, which makes these even, and that's also fulfilled. Perfect. 2, 4, 6 here. This is a 1. All right, so we have this 6 sweeper. 6 of these are even. Okay, probably have to use that later. How much Sudoku can I do? 5 looks up, putting a 5 there. Choose one of these two. These are just 3. These are just 2, 3, 4. So 4. So 4 is one of these two. What about this pair? Yeah, we need the 3 and the 6. So the 6 looks in. So that's 3, that's 6. 6 is even, 3 is odd. That makes this 4 and 6, and this 6, and this is a 2, 4 pair. All right. So this is 5, 6. This is 1, 2, and this is 3, 4. Okay. Normally I would say we've got uniqueness here where we can't make this a 3, 4 pair or we'd end up with a unique rectangle, but do be careful in variants because variant clues like this one can resolve it. So if this was 3, 4 and 3, 4, this 6 clue could technically resolve it because 3 and 4 are different parities. So you gotta be careful there. Don't use uniqueness unless you're absolutely sure that no variants could resolve it. This is a 1, 4 pair, and then this is 2, 3, 5. That's not a 3. Let's see. So does it have to do with this then? I'm not seeing any like specific restrictions here. We need 2 odds in here. Which ones are going to be the odds? Is that a question that I want to answer right now? Not really. I don't know. I don't know which 2 are odd. Okay. 2, 1, 4. Is there anything going on here? They just see the 3 and the 6. Okay. Gotta take a step back. Oh, maybe it's this 4 here. Yes. Okay. I missed that this 4 wasn't done. So this needs to be even. That makes it a 2. 5 and 3. These are not 2s. So 3 is odd. 5 is even. So this is one of our odds for around our 6. And look, exactly what I said happened. We got this unique rectangle here that can resolve because of this 6. And so actually uniqueness would tell us that this is a... Actually, it doesn't tell us. No, we don't know if it's going to resolve it as even or odd, actually. All right. What can I do here? So we have a 3, 4 pair. So at baseline, these are 1, 2, 5, 6. That's not 5. That's not 6. So what can I do here? Is there another circle that I haven't accounted for? Maybe this 5. Okay. I need to be paying more attention. So we already have 3 evens. So we need 2 more evens up here. 2 more evens and 1 odd. 2 evens, 1 odd. What am I doing? I don't know how to deal with that. 2 evens, 1 odd. Huh. Oh, I see what's happening here. One of these 2 must be odd because of the column. There's already 2 evens in this column. So we can't get away with putting 2 evens here. There'd be too many evens in the column. There's only 3 of them. So one of these is definitely odd, and that's my second odd for this 6. And so that means that these 2 must be even, or I'd have too many odds around the 6. And so this is a 4 and this is a 6. That gives us the 5 and the 3 and the 4. That's not 5, that's not 6. 1, 2 pair. So this is 5 and that's 6. So let's just get these colored. Oops, I made 5s blue. And then this 4, yeah, oops. So this 5, we already have our 3 odds, so this has to be even. So these are going to be odd. That's going to be even. That's going to be odd, and that's going to be even. All right, now we can finish it. we're done. Cool. All right, cool puzzle, GDC, as usual. I really enjoyed the logic of the sweepers here. I really like this 1, 2, 3 triple and the fact that 2 and 3 had the same effect of putting 2 odds here, 2 odds here. So we couldn't put it here because the 2 odds here would break this clue, being a 5. Really interesting stuff. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.